Hello everyone, my name is Edmund, an intern at ChemoPower Technology from NUS Engineering, and today I will be guiding you all through my research topic, the aromas of Coke and Pepsi. First, some background. Coca-Cola and Pepsi are two of the most popular soft drink brands in the market, and most people have a preference for one or the other based on their flavor. However, as we all know, the flavor of something is based off not just its taste, but its aroma as well. Hence, we at ChemoPower decided to conduct a test on these soft drinks to see if there was a detectable difference in aroma between them. To do so, we conducted GCMS analysis on samples of these drinks. Now, GCMS stands for gas chromatography mass spectrometry and is one of the methods commonly used to analyze gas samples. We conducted GCMS to analyze the aromas of 5 different drinks, which included 3 types of Coke, Classic Coke, Coke Stevia and Coke Zero, as well as 2 types of Pepsi, regular Pepsi and Pepsi Black. We hence purchased cans of the selected drinks from our local supermarket and processed them all with the same method. In order to process the result of the GCMS, we utilized multiple different software tools. Firstly, the results were processed with ChemoPower's proprietary Smart Dalton peak detection software. Smart Dalton possesses features which make it ideal for analyzing GCMS data, as it is able to detect trace or overlapping compounds within each drink sample. Next, the results were sent to MoleculeDB for compound identification. MoleculeDB is ChemoPower's other proprietary software, and it uses an online compound database to identify and match compounds to the peaks detected by Smart Dalton. This allows us to quickly and accurately determine the identity of each compound. Lastly, after the compounds were identified, we performed principal component analysis on them to determine which compounds were the most important to focus on. Principal component analysis, also known as PCA, is a method used to quantify the differences between different sets of data. Now, moving on to the results of the samples. On this graph, we can see the number of compounds identified within each sample. We can observe that the number of compounds discovered within each sample is fairly similar, and each sample's composition, denoted by the different shades of red and blue, are similar as well. Between the Coke and Pepsi samples, we discovered a total of 109 distinct compounds. However, of these 109 compounds, relatively few are specific to one of the drink types. Only 22 compounds are unique to Coke and 29 are unique to Pepsi. The remaining 58 compounds are shared between the samples in some combination. Hence, this is not enough to conclusively prove that there is a significant difference between Coke and Pepsi. To do so, we will need to look at the significant compounds of these drinks. PCA results show that there are 7 significant compounds in the aroma of Coke and 8 in the aroma of Pepsi. Of these compounds, 4 are shared between the 2 drinks, which means that Coke, highlighted in red, has 3 unique significant compounds, while Pepsi, highlighted in blue, has 4. It is thus the properties of these compounds which we are interested in. We conducted online research to tally the so-called aroma keywords of each unique compound, which are keywords used to describe the aroma of each individual compound. The aroma keywords of these compounds were then compared against each other, and the outstanding ones from each category have been highlighted. As you can see, based on our results, the aroma of Coke can be described as being minty and terpenic, while the aroma of Pepsi can be more described as pine. In conclusion, having performed a thorough analysis on the compositions of both Coca-Cola and Pepsi drinks, we are now in a much better position to say how these drinks differ from each other. Even though their compound compositions are relatively similar, the differences in the aroma keywords of their significant compounds can give us an idea of why they smell different from each other. Thanks for watching.